Okay, Year 12 Extension 2, we're going to have a look at this example here. We're given an integral and we're going to show that this recursion formula is true. So let's start off with part A. Now, remember our recursion formula is repeated integration by parts. So we're going to apply integration by parts to this integral here. Now, I've swapped the order of these functions around compared to the original, and that's because with integration by parts, it's all about reducing the degree of one of your functions. Now, if I differentiate this, I can reduce the degree. And if you remember the formula, it's integrate the first, leave the second. Integrate the first, derive the second. So deriving the second will reduce the degree of this. So let's have a look. Definite integral. Integrate the first, so 1 minus x to the 3 on 2. Divided by 3 on 2 is 2 thirds, and don't forget I'm going to have to need a minus sign there because I've got a minus sign there. Okay, when I differentiate this, I should get back my original function. Let's double check. Okay, so integrate the first, leave the second. Right, minus. Integrate the first. And derive the second. Okay, so there we go. There's integration by parts for the first part. The next bit you've got to do is evaluate this. Now, if you put 1 into there, you're going to get 1 minus 1 is 0. If you put 0 into here, you're going to get 0. So that whole thing there becomes 0. So that means we can write down n equals 0. Now, the two minuses become a plus, so you're going to get... and also the n and the 2 thirds can come out as a constant. So you're going to get obviously plus 2 thirds or 2n on 3, integral from 0 to 1, 1 minus x to the 3 on 2 dx. Okay, that's looking good so far. Now, let's just tidy it up a little bit. So we've got in equals 2n on 3, integral from 0 to 1, 1 minus x to the 3 on 2 dx. Okay, now we do need to get an in minus 1 in there somewhere. So how are we going to get it out of this? Well, let me just have a look at what in minus 1 looks like. Look at in minus 1, it'll be 0 to 1, x to the n minus 1, square root of 1 minus x dx. So I need to, now I think I've dropped off a term I have, yes, this term, sorry. Whoops. That should be in there, x to the n minus 1 dx, too hasty, x to the n minus 1 dx. Okay, that's good. Alright, no mistake there. Now, look at in minus 1. What does it have? It has 1 minus x the square root. I need to get that out of this, don't I? So I can split this up. So 2n on 3, integral from 0 to 1. I can split this up into 1 minus x to the half, right? Outside of 1 minus x. And I'll put the x to the n minus 1 out in front there. Okay, because I want these guys together. dx. Alright, that's looking good. So that's in. Okay, now I'm going to expand the brackets here. Alright, so I'm going to take the 1 and multiply it by this whole thing. So that's going to give me x to the n minus 1, 1 minus x to the half, and then I'm going to take the minus x and multiply it by the whole thing as well there. So that's going to be minus x to the n, 1 minus x to the half dx. Okay? Now, I could write this as two integrals, couldn't I? I could go 2n on 3, close, open bracket, integral of, this should be from 0 to 1, shouldn't it? X to the n minus 1, 1 minus x to the half 0 to 1, dx minus integral from 0 to 1, and then x to the n, 1 minus x to the half dx. Okay, why did I do that? Well, because it's easier to see now. What is this guy here? That is I n minus 1. It's exactly what we wanted. So I n minus 1. And what about this integral? That integral is I n. Okay, so I've got I n here. Right, so this whole thing is equal to I n. So now I can go I n equals 2/3 I n minus 1 minus I n. Alright, now if I multiply both sides by 3, what's that going to give me? I'm going to get, to my arrow properly, I'm going to get 3I n equals 2 brackets I n minus 1 minus I n. Okay, now let me just draw a little border here, and this will come up to here now. Okay, so what does that give me? 3I n equals 2I n minus 1 minus 2I n. I think I've dropped off my term here, haven't I? Yes. Alright, see the n here? That should be there, yes. That's going to make a big difference. That should be there. And then okay. Alright, I have to rub that out. There we go. And that'll be 2n I n minus 1 minus 2n I n. Okay, so I'll put all the I n terms on one side, so I'm going to get 3I n plus 2n I n equals 2n I n minus 1. Okay, so taking I n outside as a common factor. Alright, 2n I n minus 1, and then dividing through, I get I n equals 2n over 2n plus 3 I n minus 1. Do that bit neater. Okay, so checking that. Yes, that's exactly what I wanted. Okay, alright, there we go. That's a quite interesting question. Copy all that down. And during these videos you can pause them at any time and see if you can continue and work it out ahead of me. Alright, now part B. It says hence evaluate this. Right, so let's do that now. I'll rub this out. Okay, so part B. Hence. So hence means I've got to use the formula. Alright, so here we go. So I've got to, now this is obviously I3, isn't it? So I've got to find I3. I3. Well, I3 is equal to this, isn't it? Okay. Now, but I've got a formula, don't I? So I'm going to go I3 equals, or n is 3, so it's going to be 6 over 9 times by I2. Right, keep going. So I3 equals 6 over 9 times by, now what's I2? I2 will be 4 over 7 times by I1. Okay, so did we work out what I1 was before? Yes, I think we did. Here we go. Oh no, we can keep keep going. Yep, alright, so 6 over 9 times 4 over 7 times, now what's I1? That's going to be 2 over 5 times I0. Okay? Alright, so what is I0? Well, let's work it out. I0 will be the integral from 0 to 1. Putting 0 there, x to 0 is 1, so it's just the square root of 1 minus x dx. Okay, so that equals, now we know how to integrate this, 1 minus x to the 3 on 2. Over, that'll be negative 2/3. And it'll be 0 to 1. Okay. So that, I'll take up the negative 2/3 as a constant, and then I've got 1 minus x to the 3 on 2, 0 to 1, which is negative 2/3. Now, if we put 1 in there, we're going to get 0 minus 1 to the 3 on 2, which is just 1. So it's going to give you 2/3 there. So what can I say therefore? I3 equals, just coming back from here, 6 over 9 times 4 over 7 times 2/5 times 2/3, which equals, well, it should be, did I get 2/3 there? Oh, that should be negative 2/3, my bad there. Negative 2/3. Alright, so working it out with 24, 48, 32 on 315. Yep. On 315. Let's double check that. Okay. That's not negative, that's positive. I'm going to do it. Okay. Alright, so 6 over 9 times 4 over 7 times 2 over 5 times 2 over 3 equals 32 on 315, correct. Alright, so yeah, so the minus and minus become a plus there, that's all good. Alright, that works out. Alright, so we did A and B now. Alright, now for C, we're going to write this down, just so we don't forget. I0 was 2/3, wasn't it? Yes, I0 was 2/3. That could come in handy later on. Okay, so let's do part C now. Doing well. Alright, so let's ripple this out. Alright, part C. Yep. Alright, get rid of this. Alright. Now, this is quite an interesting part of the question. Here we go. Alright, it's a big one. Alright, so part C.